A baseball diamond is a square with a side of 90 feet. A batter hits the ball and runs towards first base, that's right over there, with a speed of 24 feet per second. And my first question is, at what rate is his distance from second base, right up there, decreasing when he is halfway to first base? So if he's halfway to first base, that means he's right here, and the distance from him to first base should be 45, because that's half of 90. And I want to know how fast his distance to second base is decreasing right here. So I'm looking for the rate of change of that side right there. And if I look right here, I know a baseball diamond is a square, so I've got a right triangle there. And because it's a square, I know what that side is. All the sides are 90 feet. So I'm going to do a quick Pythagorean theorem just to find the length of that hypotenuse there. So a squared plus b squared equals my hypotenuse squared. If I rearrange that, I'll find that that hypotenuse is radical 10125. So I'm just going to write that right there. Now, I actually have the rate of change of one of these sides, right? I know that this side is closing in at a rate of 24 feet per second, but you need to ask yourself, is this side getting smaller or bigger? And if he's running towards the base, you know, the goal is for him to get there. So that's a negative rate of change because that side of the triangle is decreasing. Some other pieces of information. Let's say that this side is B, and I'm examining the rate of change of this leg of the triangle. Well, that side of the triangle is always 90 regardless of how close he gets to the base, because it's a square and nobody's moving first or second base. So the only rate of change I'm looking for here is his distance between where he is and second base. So that's the question I'm going to ask. And I'm going to use the Pythagorean theorem to figure it out. So this is the equation, again, that relates my variables. I'm going to differentiate implicitly in order to give me an equation with the rates of change that I'm allowed to plug in, because the goal here is to find dc dt, right? So I need an equation with a dc dt in it. And there he is right there. Again, I'm going to reduce the 2's. So I divide everything by 2, and I start making my substitutions. One of my legs is 45. That's how far away I am from first base. dA dt, in this case, is, what did I write? Negative 24. My other leg is 90, but the rate of change of that side is 0, so that's going to go away. My hypotenuse is radical 10125, and that rate of change is what I'm looking for. So I'm going to start simplifying. 90 times 0 is just 0. 45 times negative 24 is negative 1080. That's equal to radical 10125 dc dt. And if I divide it out, I find that dc dt is equal to radical 10125 divided by negative, the other way around, excuse me, negative 1080 divided by radical 10125, or if I simplify my calculator, about 10.73 feet per second. And I need to make sure it's a negative rate because he's moving closer to second base, right? This hypotenuse is going to get smaller as he closes in on first base there. So that's the answer to the first part. Part B asks, at what rate is his distance from third base increasing at the same moment? So that might seem like a daunting task given that we just did one related rates problem, but let's examine it. I'm going to clean up my picture here just to see what's going on. I'm still right here, and that's a distance of 45 there, and it's also a distance of 45 right here. It's going to be helpful to me because if I instead look at this right triangle, that's third base right there, this hypotenuse would represent the rate at which, or how far this guy is from third base. And as I move further to first, that hypotenuse is going to increase. Now I'm just going to draw this right triangle. I'm going to try to save myself some work. This side's 45. all the sides are 90 for the square, so that's 90. If I do the Pythagorean theorem one more time, I notice that's radical 10125. Holy smokes, this is the same triangle. So I'm not going to do any work that I don't have to. I know if the rate of change of this side is 24, the rate of change of this side should be about 10.73 feet per second. The only difference now is that this hypotenuse is increasing and that 45 is increasing. If I go through the process, and if I go back to this equation that we had where we took the derivative and we plugged in, the only thing that changes here is that rather than a negative 24 right there, it's a positive 24. And if I did all the math out, I'd get 1080 equals radical 10125 dc dt, and when I divide it out, I'd get the same answer, just positive. So in this case, this is really the same problem because I'm working with the same right triangle when I fill it.